exponential model. A lot of them. And then if we consider change it into the, I forgot suddenly the name of that random variable. So it's the distribution. It will be Poisson distribution. Okay. I think that you have the class, right? The engineering mathematics, something like that. Yeah. So in your engineering statistics, you should learn the distribution and the curve. And nowadays it's getting more important, but not the traditional way. Instead, we have the huge amount of data. We can just see such a data. What is the something distribution or the characteristic instead of such a queuing model. Okay. Then you can adjust the variable, then the product. So that is a queuing model. At the time, we can use the little formula. I'm going to skip this part. Simulation, we can, instead of implementing real system, we can simulate. Like the previous, the thing, using the deterministic model, so we can simulate. If we add some other component like the process, whatever, and memory, and I/O, then it can be simulated. For example, the network is the simulator. Real implementation is one of the solutions. Sometimes you need to do that if really is critical, but it's a high cost, a high risk, and sometimes it's not practically possible. Okay, that's the end of the CPU scheduling. If you are interested to see how the program that the Professor Lee demonstrate, you can go to this website. I'm not sure whether it is still. You can just hopefully you can download or you can search the Google. This is the picture that I took 4 years ago when I visited my parents' home, and I tried to get a haircut. It's the second floor of the intersection, and I saw the situation. What happened? This car is coming from this way, and this car is going this way, and I think that there is a parking lot for the shopping center mall here. So a lot of cars coming out this way, and a lot of cars try to go to this one, but because there is no traffic signal and no policeman, this car and this car are very angry to wait for a while. So they push head in the middle of the intersection. Then what happened? They cannot moving forward. No way. So what will be the solution in this case? That's the best solution. We can explore one of them, like this car, and this car can move, and so on. Unfortunately, move back. This car maybe move back if the driver is generous. We can move back and go into this one, but this car probably never chance to close the loop. Okay, and any other solution? So anyway, this is called deadlock situation. So locking, there are different types, a lot of different types of lock. Live lock, spin lock, something lock. So this is one of the locks. Serious lock is a deadlock situation. Deadlock happen. When does the deadlock happen? It's a very greedy. Greedy means holding something. So for example, this car is holding this way, right? And try to get this intersection, okay? Waiting the car. So this car is going to this way, but cannot get this intersection. This car is also holding something. Then try to get the other. That is held by others. For example, I love this point to get, but she is having. And also, she tried to get the pointer, but I'm holding. So keep waiting until she give up that she keep waiting until I drop off forever. I will not. She will not. So forever waiting. But if this is not me, so just leave it always she can take, there might be no problem. Okay? So that is called the deadlock. That happens a lot in operating system. We can consider the driver or car as a process, and the road or the intersection and so on, this is called resource. Okay? The process and the resource. So we have a number of process, we have limited resource. If we have unlimited resource, no problem. Since we have the limited resource, it causes a problem, that is a deadlock. So deadlock, what happens when you encounter deadlock in your computer system? Hang. There's nothing. That is the computer hang. So you are crazy and hit your keyboard, everything, but still the waiting. So that is a deadlock. Computer, the operating system, has a lot of such a deadlock situation. What is the solution? In this chapter, we will talk about such a solution. But what is practical solution? Restart, Control C. Before restart, use Control C. Control C means it's an interrupt. So firstly, interrupt signal. So then we can expect something. Not always it's working. Then at the time you can reset. Restart is the best solution. But why operating system? Why not operating system take care of such a thing automatically? Why the user still wait, even though I purchase a very expensive computer system, but do I need to restart everything whenever I encounter such a problem? Why? That is always true. Operating system actually nowadays does not care. Does not care the deadlock. For example, if in this room, how many students? I have the 50-something students. If I take care, because I'm the professor, I'm taking care of all the individual, whether they're the relationship, like you guys fighting each other and do something problem or the project, something happen. If I involve all of the problem in this room, I cannot do my lecture. 24 hours are not enough. So I ignore, because you are independent and you are adult, so you can solve such a problem by yourself. So operating system is the same thing. This is a serious problem, but it's very hard to take care of all the every cases. So operating system actually ignore deadlock. That doesn't mean it is okay to have the deadlock. Instead, user application is in charge of such a deadlock. So in this chapter, in the next class, we are not going to have the lab the next class, and next week the Tuesday, instead the next week the Thursday we will have the both lab 3 and 4. Until that time we will talk about the deadlock, and also we will have the midterm exam after spring break. Okay. I forgot to have the quiz. Maybe the next week. So we will have the quiz for the chapter 6.